Alright, today we'll be trying to do maximum average subarray. I am actually absolutely horrible when it comes to sliding window. So bad. So I found a very easy one. So we're gonna try and figure this out. Hopefully it shouldn't take too long. You are given, so now let's read the problem, alright? So you're given an integer array nums consisting of n elements and an integer k. Find a contiguous subarray whose length is equal to k that has the maximum average value and return this value. Any answer with a calculation error less than whatever will be accepted. Okay. So we basically maintain a window of size that much. Okay, so k will always be the same or less than n. Nice. So in that case, we can make two variables, 1, 0, and k. There's 1, right? So this would be our window that we're just gonna move around, and then our max average, which will be the value we're gonna return. We're just gonna make that 0. Oh, there's negative numbers though. What? Okay. So the values can be negative. So, you know what? I'll just make it like negative infinity. I don't know if that's the right index, but that's fine. And while r is less than len nums, if sum of nums lr divided by k is greater than max average. Actually, we can just do like this, no? Max is equal to max average. We're gonna just move this window as we navigate through the list, and as we're moving it, we're gonna check whether or not it's greater than max average. If it does, then it'll update it. So that'll be sum nums L to R and divided by k. I just don't remember whether or not this should be r plus 1 or r, because I don't remember how concatenation, string concatenation or whatever is what do you call it, exclusive at the end, or inclusive. It might be exclusive. I'm just gonna add a plus 1. Let's see how that goes. Now we move L equals 1 and R equals 1, return max average. So I'm just gonna make sure that actually I'll just calculate this up here so that I can, oh, what the hell? This way I can just check what the hell print is. Damn. Oh, what the hell? Okay, nice. Why is this so long? What the hell? What? Bro, what the hell? How is this possible? Oh my goodness. What is this? What is this test case, my guy? What the fuck? I mean, I got it right, but I don't know why the hell I'm getting this error. Fuck it, bro. Huh. Okay, so I think it's too inefficient. Okay. So I thought my answer was right, but maybe there's a better way of doing this, dude. Okay. So I think I should keep cursum, right? Nums L R. This is the cursum. I should do +1 here, and then okay, so I should like minus the cursum from cursum so that I can just like I should minus from cursum the value of L and add R and stuff like that. But when should I do that? I think I should minus it. I should add it here now. Nums R. And then right before I move it, or here, I could go like, okay, minus that, because it's not relevant to, it's not relevant here. But this might be wrong. In that case, the first should just be like this, no? It's only taking like, if there's 4, it's only taking in like 3. But this is gonna be an empty array, bro. I think this might return an error, actually. What? Actually, this is fine for some reason. I'm so fucking lost. Okay. Goodness gracious. Okay, so. Oh, okay, that's my mistake. Nice. Hopefully this doesn't crash the damn thing. Should be easier now. There you go. Woo! That took longer than I'd like though. But this has a time complexity of O of n since we're just moving through the window each and every time. And since we're not using sum throughout the whole thing, we're only doing this like the initial implementation we had was using sum, which had a complexity of OK, where k is like the size of the window, but you know that's kind of slow if the size of our window is massive. So this is a pretty good way of just optimizing it, keeping track of cursum, and then taking it out whenever we move forward, adding it in when we're going forward. I opted to remove the +1, so it's kind of like the sliding window -1, because we'll add it here at the start of our loop. And I'm just like making this negative infinity as low as you can get, since we have negative numbers here. As for the time complexity, no, sorry, space complexity, it's just O of k, where, wait, does that even O of k? No, it's just O of 1. We're not storing any lists or anything. It's just a constant value, yeah. That wraps it up. Very cool.